Welcome you to the last session of Unit 5 Embedded Software Testing, and this is the last theoretical session of the entire embedded software testing. And in this unit, we'll try to study the test management aspects in terms of defect management, test management and control, and test management tool, defect management tool. Then after this, we will go through all the units what we have studied quickly, so that we are done with all the theoretical parts of embedded software testing. So before this, I will just go through what we have understood in the previous session about test management. So we had gone through change management, document the change request, analyze the impact, approval is required from CCB is nothing but a change control board, who will approve for the changes after the analysis is done, and the final approval will be the senior management, and any minor changes will be taken care within the team without highlighting to the higher management. So making of changes will be done through a checkout check-in process, which is nothing but the configuration control process, where we check out, we will take out from the repository, and once we update, all the reviews are done, we are going to check in back so that a new version is created and the changes are available in the repository. So that's how we do the changes onto the corresponding document, code, test aspects, test cases, anything that are part of the test cases, that are part of the configuration items, CIs. Then we are going to close that change, particular change, saying that it is baselined or it is available for the release or delivery. So that is what is the change closure. Then we had gone through incident management. So we understood what is an incident, any significant unplanned event that occurs during the testing or any other event that requires some investigation and resolution of that particular incident. So the incident could be due to a fault, intermittently it has happened, unexpected, so the results are incorrect, test was not performed correctly. So we can raise the issue incident against the unexpected behavior, or it could be self whatever that particular tester or engineer trying to test it as well, because testing may be an incorrect way of doing also, that is also can be called as an incident, so that there is a need for correction of the incident or the resolution for that particular incident. So in incident management, we first identify or detect and record what is that incident about, and details of all that incident. Then we do an analysis and classification priority, like whether these 5 incidents have happened, how we can prioritize, what is impacting that, whether it is a showstopper for the rest of the program to continue, or it could be testing, execution, whatever it is. The next one is the investigation and detailed analysis. We will try to investigate what is the cause, where the problem was before that incident had happened, and we try to put a mechanism for recovery, how we can recover that particular incident, whether we can fix that code, fix that design or requirements, or the test approach itself is wrong. All this will be part of the resolution and recovery. Then we will have a different stages of incidents, like new, open, wait, rejected, include into the build, verified, closed, etc. And every revision that we are going to release deliver as an artifact should identify a clear history of what is going on in the particular CI or configuration item. So every configuration item is supposed to have something like this mandatorily, which will identify the particular revision number, why it is, what revision number it is been numbered, and on which date it is been revised, who is the author, who is the reviewer or approval, and what are the changes that particular revision number has undergone. Similarly, upon the next change, we are going to highlight it as revision number 2, 3, 4, like this. Each one will identify clearly. So what is the revised details or updated details or the change details that are undertaken within the particular revision. That's what we do. That is about the revision history, how we are going to mention for each of the CI. Then after understanding the configuration management, incident management and all that, we went through the need of CM tools. So all the testware has to be having identified in a physical location or a particular repository. So to control and manage that, we need CM tool or a configuration management tool such as MKS, VVCS dimensions, SVN, etc. So this is basically used for the CI. It could be a development, it could be a testing, it could be a test case design, any documents, any Excel sheet, anything that is part of the project. All this will be controlled and managed through the configuration management tool. A glimpse of how the configuration management looks, we try to understood, and it has various windows which will highlight in different colors in terms of what is the status, when it was updated within that particular project, and whether it is inline, whether it is a baseline, and if it is baseline, how many elements of that particular baseline is ready for use, etc. All this will be part of the tool. As a display, you can see it. You can configure the tool also. It doesn't matter. Usually, the tools will allow user to configure the way that project has to be fashioned. Then we understood about the test management in terms of planning of the test project, various aspects of test management and its effort in terms of test management, methodical support, technical support, domain expert, test configuration management, and tester. All these efforts for each of the activity under test management will be updated with a start and end date. This is something like a planning document or a management document. Against this, tracking will be done. How much effort has gone here and all that. And in one of our sessions, we studied about the variance. Like this is a plan, this is a management plan, and against which how much we have consumed, how much is left over, what is our trend, and what is the variance from schedule, what is the variance from effort. All this will be part of the test management we are going to take care. Also, we studied about how the test processes are related to the software V model. We understood about multiple V development life cycle. You can see model, prototype, and final product, and each has its own V model, and that's why it's called as multiple V developments or a life cycle model. And that life cycle model has on the right hand side edge as a test aspects or test activity, and that is on par with the left hand edge of the particular model or prototype or the final product development. So that is how it is aligned with the V model. In detail, the same thing is been explained with this diagram. This is from that book called Testing Embedded Software by Bart Brockman and Edwin Notenboom. More details are provided, and we have gone through this in our one of earlier sessions. I think it's in unit 3. Yes. So similarly, the different V models, various V models we have gone through. On the right hand side, you can see how the testing is aligned in terms of regression testing, random testing, statistical testing, certification, all that. The ultimate aim is to reach the rightmost edge of the upper side of the V model, basically to release that particular activity which is identified for that particular V model, and we are going to define a release criteria. The next type of testing for as for a of the interest in embedded software testing is testing design by contract. Here the approach uses the documentation only to capture the design, but it will encourage basically sort of an interaction among different developers. So that particular developers are allocated work like a contract, and they will provide the support in terms of interacting each other and providing the solution. So that's how we do the test. The specification is called as contract, and that contract will be developed after the interaction is done with the different module owners and the system owners. Then we had gone through a process called agile development process. They basically use in short duration time to market sort of a application, embedded application or embedded testing, embedded systems, which is totally away from normal and software development process. So the current process are too heavyweight or too cumbersome in terms of documentation, process, and all that. So all that will be bypassed in the agile development process. And the current software development is too rigid. It's difficult in terms of changing requirements, incompletion, and short development cycles. All these are very difficult to align with the current model. So the process itself is deviated in terms of doing the agile, where it is totally aligned with the business process or value to the business. Basically, it brings up, and different methods of agile are available, like such as extreme programming, Scrum, like this. So most popular ones are Scrum and XP, extreme programming. So basically, the values are something like individuals and interactions over process and tools, working software over comprehensive documentation, customer collaboration. We take care more in the agile process than the contract negotiation and all that for changes and all that. Responding to change over following a plan. So as soon as the change comes, we are going to start working on that, implementing and all that, instead of going through the plan, process, analysis and all that, because there's no time for all this. So it's a quick process mechanism. Extreme programming, adaptive software development, dynamic system development method, all are different types of methods that we have. You can see more details, and say non-profit organization, they define and they promote agile development. Basically, companies like NXP or any consumer electronics group, they follow this to develop the prototypes and all that. They adopt this agile Scrum development process. Of course, testing is also part of that Scrum development. So they will identify their own mechanism to align with the agile development. So you can see that example what I have put. They call it as a sprint backlog. So every day, based on the frequency, that backlogs will be cleared and identified. Action is taken care. So for example, if it's a 30-day project, within 24 hours, there is action for each of the development team or the stakeholders. They will try to act on that so that they reach the deadline. As I said, agile testing Scrum process also will be used. There is no specific or dedicated tester in a formal Scrum process. Testing is carried out by the developers with unit testing mechanism. Testing coverage is carried out by the product owner or the client. He takes care of how much covered and all that by seeing the report against the specification. So the testing is taken care by each sprint. Sprint is something like a sprint backlog on a daily basis or whatever it is, as per the definition. And there is the acceptance criteria for each of that, and that will be taken care. The next type of thing is test-driven development. So basically, we write the test for a specification, and against that, we will try to develop the project. So basically, the project is oriented towards test driven. Surrounding the test cases and all that, we are going to develop it. So we write a test case that fails, write just enough code for that to fix that fail mechanism, and we repeat that the complete testing is taken care and the development is done. Okay. Test management and control. What to do when things happen that affect the test plan. So if there is a hit on the test plan, we are going to definitely work on the test management and we need to control it. So we need to reallocate various resources. We need to change the schedule. We need to change this environment. We need to redefine the entry exit criteria and number of iterations changes we need to take care, and any test suit related changes are there, that also we need to see the effect, and release date also we need to postpone or update it. That's what we had studied in the earlier session, session 3. Today we'll try to quickly understand the test management in terms of test management tool. So we know that the reallocation of resources, changes to the entire test life cycle artifacts need to be managed and controlled. So that is what we do with the test management tool. So the tool will basically take care of all the artifacts, and it will highlight, and it will provide the tracking mechanism in terms of where we are in the testing project. So that report will be used by the test management, and I will try to adopt as per the strategy that is going to work out for the release. So basically, the test management tools provided by tool vendors offer only the functionality to store test cases, scripts, and scenarios, and sometimes integrate defect management, something like Bugzilla. Test management example I will try to tell you what we had used in one of the projects. So the test management identifies test cases, scripts, scenarios. All this will be taken care with the test management tool, such as test link. I think one of the sessions, practical sessions, we'll go through this, how this tool works, and we'll try to create a exercise sample project identifying the test management test cases and scenario. Similarly, we need to identify the defects using defect management tool. All this will be basically used for managing the test. Something like Bugzilla tool is used for test management and defect management. So basically, it offers to store all these artifacts, scripts, scenarios, bugs, and all that, and they don't store plans. So plans test management manager has to see, and this tool will provide the numbers and all that artifacts, and he need to align that against the project schedule. So they have no facilities to store test plans and project schedules, but this type of test management tool is not basically useful and controlling the activities, but they need to be aligned manually by the test manager. That's what they do. But the good thing is the tools will have the ability to link system requirements to test cases, such as test link. We can link. So how many test cases have failed, passed, etc. will be taken care. Okay. So these tools offer the ability to keep track of the coverage of test cases. This is very important thing. How many test cases have been done? How many test cases are failing, passes? All that coverage reports against the system requirements or the specification requirements. These tools will provide. In addition, they become very useful if system requirements are changed, or if it changes, the test manager is able to show the impact of these changes and how many test cases we have to execute or re-execute if one requirement changes. So that test, so those things can be highlighted with the tool basically and report it accordingly. And the showstoppers in terms of any serious issues or any bugs that have been uncovered, all this will be highlighted with the test management tool. The other part, as I said, is a defect management tool, such as Bugzilla can be used. Defects detected during the test process must be collated in an orderly way, basically. because all the defects need to be used and controlled. That is where this tool is useful. For a small project, a simple file system with a few control procedures is sufficient. One Excel sheet sort of a document is enough where we'll highlight manually. But as we progress throughout the entire project, it may not be sufficient to maintain through simple file system mechanism. We have to live with the complexity, and for that, it's advised to use defect management tools such as Bugzilla. Usually in the industry, they have their own tools defined actually. Bugzilla is a royalty free. It is not a royalty free thing. So if commercially you want to use it, you need to pay them, or you need to go for the royalty licenses and all that, copyrights and all that. But in general, what happens is the embedded software industry, they use their own in-house tools to maintain the defects and test artifacts, and against that the management will try to correct it and report to the customer and all that. So more complex projects need at least a database with the possibility of generating progress reports showing, for instance, the status of all the defects or the ratio of solved to raised defects. Several tool vendors have developed the defect management systems. All these are designed around a database system and have tracing and reporting skills. So definitely all the repository with regard to defects will be stored in the database systems, and the database systems will be smartly used by the UIs, and they are used to report and can be used to track it. The tools have the ability to implement a workflow with security and access levels. So admin can define who can check in the files, who can put into the repository, who can update it. So that workflow or the work instructions can be defined, so that the individual having different levels of access, like developers can have access for development level, and testers can have a development cannot have development access, but they can read, they cannot write, and all these sort of a control mechanisms will be defined by the admin for using the defect management tool. And also, as long as that defects are opened, closed, in progress, hold, and we can set up a notification in terms of email facility, and some of them are web enabled. So you can trigger that in the web itself, so that once the stages have been moved, automatically the communication will be happening to the respective stakeholders. The defect management system is used to store defects, trace them, and generate progress and status reports. The tracing and reporting facilities are almost indispensable as control instruments. So very important aspect of the defect management. So with that, we come to the conclusion of test management tool and defect management tool in this session. So with this, we are going to end the embedded software testing the last session. So now we will try to okay. So this next few minutes, I am going to discuss and highlight about what we have studied overall in the embedded software testing, right from unit 1 to unit 5. Okay, so the units are divided such a way that all the aspects of embedded software testing is taken care, and in unit 1 we studied regarding which one, fundamentals of EST, embedded software testing, right? That is the first session we had, and in the second session we understood about testing methods. Third one is on static analysis, and code reviews. So the fourth one is basically the software integration. Fifth one is nothing but test management, because these 5 sessions are 5 units are very important part of the embedded software testing. So that is how it has been. The course has been divided that way. We'll try to go through as a pointers what are the things that we have highlighted in each of this. So we started with the fundamentals, then different testing methods, dynamic, white box, black box, and all that. Next one is on the offline part of that, like static analysis, code reviews, type of reviews, and all that. Then we understood about hardware, software integration methods, and regression, and all that. The last one is about the test management in terms of test planning, test life cycle alignment with the development life cycle, and tools that are used for managing the tests as well as the defects. So that is how the entire course is being parted, and we have gone through them. Okay, so in unit 1 it was about the fundamentals of testing. It was an introductory session to embedded software testing, and we had gone through embedded system basics, embedded system environment, embedded C glance, because embedded C code is a specific code, and that is a separate course, of course, by itself, and we try to understand the basics of that, and compilation, linking, and all that basic parts of that embedded C language and the embedded systems we understood in that class. Why I took embedded C is because most of the 90% of the projects that are there in the world for embedded systems are developed basically using the C language. So that is why it's very important to understand embedded systems basics with the C, embedded C language, and fundamentals about that. Then we had studied about V&V, validation and verification, cost of embedded software defects. We had seen a graph plotting various stages of embedded systems. We find defects, it will be difficult to control as we progress towards the end of the project. So it has to be fixed in the earlier stages. So that is why we need to have a right sort of a testing mechanism. So that's what we understood about the complexity. Then test process basics. So what are different processes that are followed, like test cases, procedures, then the scripts, then the execution on the environment. All these are basics. And embedded software system testing basics setup. How are you going to have a setup? So we had gone through the setup, how the system is communicated with the target board as a white box, how it is communicated with the target board as a black box, and how the reports are being used, how the scripts are driven. All these basics we understood with a good example of a diagram, and we also understood about the development environment, test environment as well. So continuation of the embedded software testing fundamentals. Test methods we had gone through, like acceptance, system integration, and component level testing, the various levels of testing. Then principles of test case design and procedures, how it looks like with an example we had gone through, and how we can do the testing and debugging on the target and on the system we had gone through. Test planning, like what is the goal, purpose, what are the contents of the tests, planning. In the planning process we had gone through. Then we studied about example test plan documentation and test specifications. Also we try to lay out example test procedure. Also we had gone through testing standards in terms of guidelines and rules and all that. how the testing document should be developed and testing should be carried out. We understood. Also, we had a few questions and answers exercises we have made in the first unit, and we had drawn a block depicting various levels of testing, and those levels are unit, integration, system, and acceptance testing basic. Definition of test harness, test bed, test setup, host and target based systems. During development stage, how it looks like. During testing stage, how it looks like. Then target based debugging and testing. We have three various types of them: simulation, emulation, and target monitoring. Each of them we try to understand and advantages and disadvantages of them, and collaboratively we are going to use it for the embedded software testing. And tools, what are the tools entirely in the embedded software testing that are used, how they are categorized, and we try to put a list and a snapshot of the embedded software testing tools and it will be listed as part of the planning, test planning. And setup, software environment configuration and tool snapshot we had gone through. Definitions of entry and exit criteria for embedded software testing, the various phases that it goes. Then PM method we understood with LITO principles, software lifecycle, entry, exit criteria, prototyping lifecycle and example we have gone through. A formal lifecycle and example we understood. V model lifecycle mechanism for embedded software development testing we have gone through, and different lifecycle processes with an example of entry exit criteria we have studied. Lifecycle process example we took a consumer electronics example where different stages of life process, how it passes through each other, and automotive embedded projects testing phases and process also we studied to understand. Then multiple wheel model lifecycle based on that famous embedded software testing book we referred and understood. In the same way we also went through the V model, multiple V model test activities, nested multiple V model, testing by an independent team, master test planning, principles of embedded software testing. About I think 10 principles we have studied about embedded software testing, which is highlighted in one of the embedded book. That after that we came to conclusion about the embedded software testing, embedded software systems, basics, setup, planning, and all that. Next we started study on the unit 2 in detail of embedded software testing. The first one being testing methods, and testing methods have the various chapters, various sessions about dynamic testing, static versus dynamic testing context, dynamic testing types, black box, white box techniques, testing techniques, strategy in general and in specific depending on the complexity and the nature of the embedded software testing under test case selection methods, black box and white box testing coverage aspects, advantages and disadvantages, black box testing, how to carry black box testing, how to draw various test cases and selection, and in that we studied the fundamentals and the basics about black box testing in terms of equivalence partitioning, boundary value analysis, state transition, or event transition testing. So these primary methods of black box testing we had gone through. Black box testing examples, valid and invalid equivalence classes, boundary value analysis, its applicability, examples, and I think we took the temperature, so the sensor example with high and low values. So what are the values we can feed? How we can use techniques in terms of black box testing using boundary value analysis, equivalence classes, coverage aspects also. State transition testing. I think we had gone through the VCR example or something like that, and the various events, actions, activities, states, and transitions, how it is going to occur and how we can test it. We had gone through. we had an exercise example with a UI embedded instrument, 5 operation methods or modes. In that example, we went through. We try to understand and put the various testing strategy. Test or state transition testing techniques, state event table. We had gone through with an example. Transition tree, legal, illegal, and God test cases for that state events. We see an example of state events and transition testing, transition tree drawn and gone through. The next type of testing method is model based testing. We understood the basics of model based design, model based testing, taxonomy of model based testing. We use the various instruments for that models such as MATLAB and all that, and accordingly we are going to draw test strategy for that particular model, and we are going to take care of the testing aspects of the model based design. Then dynamic testing, black box and white box testing approach, coverage testing in terms of structural coverage and statement coverage, decision or branch coverage, condition coverage, other types of testing like data flow testing, branch condition combination testing, modified condition testing, which is also called as MCDC, LCSAJ, its principles. Then unit testing and software instrumentation, what it means and how they are used with the various tools. Then test driver and test steps definitions we had. MCDC from D170 perspective or importance, we had gone through few slides. Then coverage testing tools, vector cast, LDRA, RTRT, logic controllers. We understood what they do, and I think one of the practical sessions we try to see possible in like that one of the tool we can use it with an example project. Performance analyzers, testing, timing analysis, profilers, debuggers, and all that. We can develop the test strategy and do the testing of the embedded software testing, testing tools and lifecycle, test automation techniques, test suits, risk-based testing we understood, and we had defined about dry run and formal runs definitions. The next one is the third unit, which is about static analysis and code reviews, where we do static testing and analysis, reviews, inspection, and all that. And we had drawn differences between static testing and dynamic testing. Both are complementing each other. Both are needed. Static analysis has control coupling, data coupling, static matrix analysis, AKB complexity, cyclomatic complexity is called out, and few examples we had gone through with a call tree example generated from the tool, and lines of code of the execution, fan in, fan out, nesting levels in terms of generating the metrics, static analysis tools like understand for C++, polyspace, coverity, QAC, Cantata, LDRA, testbed, etc. They are used. Mr. Rule Checker, PC Lint, Logiscope Rule Checker are used for seeing the report of the particular embedded software testing aspects in terms of code, how they are used. Call tree analysis, worst case execution tree analysis, stack analysis, stack overflow, and coding standards and rules which are applied in the embedded software development will be checked in the tools and they reported. And test metrics, quantification, test metrics lifecycle, metrics types, software testing metrics in terms of various metrics that are being generated for embedded software testing, and defect acceptance, defect rejection, execution productivity, test efficiency, defect severity index, automation coverage, effort variance, schedule variance, scope change. All these definitions we had. Metric representation, how they are being reported on a daily basis, weekly basis, and trend charts, how they are shown into the higher management of the customers. It's a burn down chart. Suppose the Next set of activities is going to take 1 month, and how are you going to reach that 1 month? Using the burn down chart, we are going to predict and report, and as we progress we are going to update it and report it. And the metrics capture tool, there are various tools that are used for managing the test aspects, defects aspects and all that. Defect management such as Bugzilla is being used. The next unit is about software integration testing, which is also an important part of the software testing. We had defined about integration testing. What is integration? Definitions of system integration, system hardware integration, system software integration, where we use the software module. In system hardware integration, we use hardware and software together. We are going to build and integrate and test it. And types of embedded software integration testing: big bang, bottom up, top down. And considerations for integration testing and its importance we studied. Integration test strategy, comparison of various strategies like top down, bottom up, big bang and all that we had gone through. We had a comparison about it. Then hybrid integration test strategy, which combines both the top down as well as the bottom up integration test approach. Then we have a centralized integration, layer integration, client server integration, collaboration integration, etc. Based on the type of or the nature of the project, we are going to decide and do the software integration testing. Then integration testing environment, how it looks like: system integration test, integration from use case perspective, specifically used in UML type of projects, and we use that use cases to generate the test cases. Then we had gone through regression testing, which is nothing but retesting and regression testing. Definition of regression testing: test strategy, test areas, test automation in terms of batch execution and processing. Change analysis and relative importance. Use case example we had seen. Prioritizing regression test cases, and what is the basis for doing that priority and all that we had gone through. Test case maintenance, because it's very important, because once the embedded software testing, basic testing is done, it is bound to update or modify over a period. And how are you going to maintain it, the project? What are the steps that are involved for maintaining it? What are the test cases we are going to exercise for the future versions of the different embedded software releases? And the build process we had gone through. And the last unit is about test management, which we have concluded in today's session. It talks about configuration management, test management, configuration management elements, CM process, SCM. It's software configuration management, activities such as planning, software configuration index control, status accounting, software configuration audit. These are different activities that are used for SCM process example and tasks, configuration control and SCB, software configuration controller board, configuration items, guidelines and life cycle also we have gone through. And SCM phases like initiation, planning, execution and closure also we had gone through in one of the session. And the important thing is about the version control or the revision control, and how are you going to do a baseline of the artifacts, workspace management in terms of the repository, how that is being used by development team, testing team, or the configuration control people. Admin basically manages that, and change management and incident management aspects also we had gone through. Last part was about CM tools, USCS, SV and MKS, and test management aspects we had studied in terms of testing process, which is in relation with software V model, design by contract, part of the testing, agile development process, agile development scrum process, agile testing scrum process, test driven development, test management and control, test management tool, defect management tool, So these are part of the test management. So that is about test management in Unit 5. So there are 5 units of embedded software testing which we had gone through. So with that we come to the conclusion of all the units of the embedded software testing. So in the next 4 or 5 sessions we will try to cover up the practical aspects of embedded software testing. We will divide accordingly the various elements that are used for embedded software testing in terms of practicality. Okay.